All right, in this video, we're going to look at example number 6, which is all about finding average rate of change. I know I have another video, but this is just more good examples. So for a couple of these problems, I'm going to use Calculate 84, and then for one of the problems, I'll use Desmos, just so you can see the difference depending on what you are comfortable with. So for the first problem here, it says find the average rate of change over the interval -1 to 1. Given this function. Now, for this first one, I'm just going to go ahead and use Calculate 84. All right, so I'm going to go ahead and split screen with that. And I know I've mentioned it, but if you haven't put Calculate 84, if you haven't downloaded it yet, please do it. It's a great function. It's a great tool. All right. So while I was mentioning that, basically what I did is I went into y equals. And what I'm going to do is type this function in for y equals. So 4x squared plus 8x minus 12. It is always good to take just a second and make sure that what you just typed into your calculator is in fact what you're supposed to have typed in the calculator. I cannot tell you how many times I have missed a value. I've put a plus sign where there's supposed to be a minus sign. So just take a second and make sure it's good. Now, I have no reason to look at the graph at all, so I'm not going to. What I am going to do is hit second and graph to get to my table of values. Now, this table of values is clearly not where I want it to be. I want to find out what's happening at -1 and 1, so just scroll up until you get to those values. Okay, so I'm going to steal two pieces of information from our table of values here. At -1, my function is -16, and at +1, my function is 0. All right, so at this point, I no longer need the table of values. Right here was -1, -16, and then 1, 0. And we've done this a few times, but we're going to do average rate of change. So take one of your y values, subtract the other y value, and then subtract your x's in the same order. Okay, order doesn't matter with what you start in terms of your y's, but once you pick this first y value, you have to pick the x value from the same ordered pair, or else you're going to have some problems. Okay, so 0 minus -16 is going to turn into +16, so that's going to be just 16 there. Same thing in the denominator, you have double negative, so plus 1 plus 1 is 2. So your average rate of change over that interval is 8. There's no context here, so there's nothing else you need to do with it. You are now done with that part of the problem. There's a second problem here. Find the average rate of change over the interval -3, 1. All right, so let me make sure I identify that interval. And this time we have this nifty little function. Okay, so again, I want to find out that interval is really two different x values. So I need to figure out the y values that go with them. So what I'm going to do on my little calculator here, I'm going to go and hit y equals. I am going to clear out this current function, so I'm just going to hit clear, and then I'm going to type in the new function. So -2x squared minus 4x plus 16. Take that second, double check your work. So -2x squared minus 4x plus 16. All right, I've got the right equation in. I don't care what the graph looks like. It doesn't matter. So I'm just going to hit... sorry about that. Wow, everything's just closing and shutting, and I'm having weird things happen. Okay, let's try this again. So I'm going to hit second and then graph to get to the table of values. I think I somehow managed to take a screenshot of what was going on here. That's all right. All right, so -3 and 10, and then +1 and 10 are my two ordered pairs. Okay, so take one of your y values, subtract the other one. Now, these y values are identical, so it really isn't going to matter order here. I tend to go from the second one here, so I'm going to do 1 minus -3. Okay, so 1 minus -3. 10 minus 10 is 0. over 4. Well, 0 divided by 4 is 0. Okay, so your average rate of change between those 2 points is 0. All right, so those 2 examples I just did with Calculate 84. I'm going to show you how to use Desmos to do the second or the third function here for this example, this final one. All right, so let's go ahead and make Desmos split screen. Maybe. There we go. All right, slide that over so it's a little bit smaller. So basically with Desmos, I want to put this equation in. Now, instead of k of x, I'm just going to use y equals. So y equals, and again, everything after this is just follow what it says. So x to the third. And you may see, obviously, as I'm writing here, things are kind of happening with the graph. I am totally ignoring all of that right now because I haven't finished putting in the entire equation yet. And so I don't really care what the graph looks like just yet. Oops, hold on a second. I need a decimal point in there. All right, always a good idea, double check what you've got. X cubed minus 3x squared minus 4x times x minus 0.5. And I'm sure that started with a y equals. Let's go ahead and slide that over. Yep, there's my y equals. Okay, so I've got this pretty little graph. The graph is nice. It's actually not terribly helpful though. So this one, I want to look at this function, or the interval from negative 1.5 to 1. All right. So my function here, I want to change this to a table of values. And I'm going to hit the little gear button here. And immediately I see this little table. So select table. The table's been created based off of what equation we have. Now, 1 is one of the values I want, but negative 1.5 isn't in this table. So if you click down here at the empty space, just tap in there, you can actually type in negative 0.5, and you get the other value. So let's go ahead and mark these. So negative 1.5 along with 8.25. And 1 goes with negative 3. All right. So if we set this up, I'm going to do negative 3 minus 8.25 over 1 minus negative 1.5. So I did y value minus y value over x value minus x value. Okay. So this is going to be negative 11.25. You can use Desmos as it's written here, okay? And then positive 2.5. And then if I divide those, I'm going to get negative 4.5. All right. So you can either use Calculate 84 or Desmos. And really, if you had other technology, you could use that too, but that's how you can use those for these problems. If you have any questions or concerns, please let me know.